So I cannot put into words how long this review took to put together. I had to Frankenstein together so many different handouts and so many different former assessments, so many different past assessments. It was absurd how much time went into this. But the goal was to present the information in as close to an assessment format as I possibly could, just to try and experiment to see if um, yeah, just to see how you did with an assessment like format. Um, yeah, so let's see, let's see how you do. This is the review for assessment 5.2, and as such, we'll treat it like we're treating an assessment review. Um, I a assessment coverage review. We're the we're just going to do it. We're just going to do it. So 1 through 3 classify each triangle by its angles and then its sides. So looking at the angles, I've got two acute angles, but I've also got one massive obtuse angle. So it's going to be an obtuse triangle. And then by its sides, I've got two congruent sides. So that just means that it is an isosceles triangle. There we go. All right. So for the second one, going by its angles, I only have the one angle that I really care about right here. That's going to be a right triangle. And then as far as the sides are concerned, I don't see any congruency markers. I don't see anything that says this side equals this side equals this side. So that means it is a scalene triangle. All right. Now for this last one, I've made a bit of a show talking about um, what this can be called or how this can be labeled. If you just called it equilateral and you wrote equilateral for both, I would not mark you off, and I stand by that. But technically, if you also wrote this, I'm not even going to say it, that would be fine. But if you wanted to write the real answer of equilateral triangle, you'd be fine. So that would be how you would So that'd be how you would talk about those ones. Using the diagram below, write a congruent statement and then all pairs of congruent parts. So again, this kind of goes back to what I was saying about the importance of being able to write a congruent statement and noting what parts are super important, and the order of the congruent statement as well. So triangle DEF. So the first part is already written out for us. So DEF is going from reference angle 1 to 2 to 3. All right, well, that's pretty straightforward. So DEF, and so the other one would be D to G to F. So that one's pretty good. So reference angles. That's yeah, well, um, technically it's angle D to angle D, but as I mentioned with one of the earlier assignments, and I'm definitely going to have to mention this when I'm talking about it in lecture. If you have a shared angle, you can't say angle D equals angle D. And you're making a reference to a congruent statement. If you have a shared angle, you can't do it. So you would have to say angle EDF is congruent to angle GDF. And then you could get away with it. Now for the second one, you could get away with saying angle E is congruent to angle G. That one's perfectly fine because if you're saying angle E and G, everyone knows what you're talking about. Now for the last one, I'm going to have to go with the EFD is congruent to angle GFD. Okay. Now for the sides, we're just basically going to follow the sides as we go. So DE is congruent to DG. And it should go without saying that when I'm referring to the sides, we're going to use the line segment side notation because none of these are lines. All of these are line segments. So you got to make sure that we use the right notation for it. GF or FG is congruent to EF. And then finally, even though it is, again, a trivial statement, DF is going to be equal to DF. All right. Let's see. If LMN is congruent to QRS, what is the value of X and Y? All right. So this is another one of those examples where I say if you have a congruent statement, if you have two triangles and you have to solve for something and you have a congruent statement, for the love of everything, please, please write out your reference angles just to start out with. So I've got L goes to Q, M goes to R, and then N goes to S. So if I'm trying to solve for X, let's see, is between reference angles 1 and 2. X is between reference angle 1 and 2, and it's also between reference angle 1 and 2. All right, so what I'm going to do is I'm going to set X equal to each other. So 3X minus 9 is going to be equal to 2X plus 11. Move the X's to one side, so that gives me X equal to plus 9 gives me 20. Plus 9 to one side, plus 9 to both sides gives me 20 on this one. Minus 2X to both sides gives me X equal to 20. So now I've got Y. So for this one, this is reference angle 2. This is also reference angle 2. So I'm in the same situation with Y, where I've got 2Y minus 40 equal to Y plus 10. So that leaves me with Y equal to 50. Because Y subtracted from both sides gives me just one Y. Then 40 added to both sides gives me 50. So there we go. All right, find the value of X and Y if triangle ABC equals DEF. So again, for the love of everything, optional drawing. No. A, B, C, D, E, F, and it doesn't have to be to scale. It doesn't matter. So AB equals 7, BC equals 9, AC equals X plus 11, DF equals 3X minus 13, and then DE equals 2Y minus 5. Okay. All right. Well, again, if you make the drawings, if you make out the drawings, these problems are not a problem. These problems are not an issue because I'm looking at the drawings. I have to solve for X. Oh, all right. Well, if these are congruent to each other, ABC, DE, ABC is congruent to DEF, then AC is congruent to DE. Yeah, that means that I can set 3X minus 13 equal to X plus 11. Subtract X from both sides, add 13 to both sides. That means 2X equals 24. X equals 12. So for Y, that gives me 2Y minus 5 equals 7. 2Y equals 12. Y equals 6. So, not optional. Do your drawings. See how fast and easy that was when I did my drawings? Do the drawings. So, for the next one, we have to decide whether or not the triangles themselves are congruent. If yes, explain why. If no, explain not. With this one, it's a relatively straightforward. We don't have to do the full proof. We just have to kind of look at it. And this is really more of a memory game to see if we remember the what's the word? To see if we remember the theorem just based on what we're looking at. So, are the triangles congruent? If yes, explain why. You just have to state what the theorem is. Are they congruent? So I see a pair of vertical angles here for this one. So I've got a side equal, I've got an angle equal, I've got a side equal. So I would say yes, side, angle, side. And if AEB is equal, I'm going from a point past side 1 to the angle through side 2. That would mean point, side 1 through side 2. So that would be, if AEB, that would be CED. Because again, when you're writing the congruent statement, the order absolutely matters. And if the test is choosing the order to start out with, then you have to follow the same path through the points that the test lays out. So if the test is going from point A through congruent path labeled 1, through the angle, through congruent path labeled 2 to the last point, you've got to follow the same path. Point, congruent path 1, angle, congruent path 2 to the point. So if it's AEB, has to be CED. So there we go. Let's see. I don't have any so with this one, I don't have any information about the angles. So that pretty much restricts me to 2 of the theorems. I'm either going to be using the hypotenuse leg theorem or side, side, side. I don't have a hypotenuse, I don't have a right angle, so that pretty much limits my options. I've got 1 congruent side, I've got 2 congruent sides, and then I've got a shared side, which is obviously going to be congruent with itself. So I'm going to say, yes, they are congruent by side, side, side. And if it's going from distant point and then up through the shared side, if their congruent statement is starting from the distant point here, and then it's going up through the shared side, which is a polite way of saying it, distant point going up through the shared side, then the other triangle will start at the distant point and then up through the shared side. So that is also going to be QPM. All right. So for this last one is tricky because this last one's tricky because we just have an angle. We've got an angle and a side, but we don't have anything else. The test writers are not shy about putting right angles where right angles should be. They're not shy about putting congruent angles where congruent angles should be. So basically, W could be anything, R could be anything, T could be anything, and if T could be anything, then these 2 angles could be anything. So the only thing that we know is that angle A equals angle E, and then AT equals ET. That's all we know. We don't know anything else. And so there is no theorem that we know that allows us to say that they're congruent based on a single angle and a single side. So to be clear, it's not that they're not congruent, it is that we cannot prove that they are congruent. So congruent, no. Why? Not enough info. That'd be a perfectly acceptable answer. All right. So for questions 10 and 11, find the value of x. Oh, all right. Well, this one, all right, I can see where these ones are good. All right. Which had a little bit more space, but we can work with it. So with this one, 3x minus 10, I'm going to set this one equal to 2x plus 4. The same way that we've been doing with isosceles problems and isosceles triangle problems. So that's going to give me x equals 14. Oh, well, I guess I did have enough space. I take 2x from both sides, so that gets rid of it on this side. That gives me just x. I add 10 to both sides, so that gets rid of it here. Makes it 14, so, oh. Well, all right then. I guess it didn't take too long. Didn't take a lot of space. All right, now this one's actually pretty impressive. So for this one, I've got a 90-degree angle. And if you remember, the interior angles of all triangles have to add up to 180. So if I've got 90 here, that means that I have 90 degrees inside this triangle that are unaccounted for. But I also have that it's an isosceles triangle, which means these 2 angles have to be equal to each other. Knowing that these 2 have to be equal, that means that of the 90 degrees that are still remaining, each of these has to be an equal portion of that 90 degrees. So that means that 2x plus 3 has to equal 45. Because if I have 45 degrees plus 45 degrees, that's 90 degrees, plus the last 90 equals 180. So I'm going to subtract 3 from both sides. That gives me 2x equals 42, x equals 21. So there we go. All right, the last two are, well, I kind of like these. I think they're a lot of fun. We'll go ahead and get started with them. So with angle 1, it's the inside triangle. It's the inside triangle here. So I've got 90 degrees and I've got 29. And so in order to find angle 1, I have 90 degrees, I've got 29. So it's going to be 180 minus 90 minus 29. So angle 1 is going to be 61. Angle 2, if you take a look at what angle 2 is going to be a supplementary angle with 29. So 29 degrees here plus angle 2 is going to equal 180. So I'm just going to take 180 and I'm going to subtract 29. That's going to give me 151. So we're in good shape there. So now I have to find measure of angle 3. Well, if I know angle 2, then I can take again 180 minus 151 minus 17. And number 3 is going to be 12. So I guess it really wasn't really too big of a deal. So I mean, the real key with this one is as long as you remember that the interior sum of the angles is 180, you're in good shape. Yeah. I suppose another way you could have done this one, if you didn't want to use the supplementary angle, you could have used the external angle theorem for number 2. The external angle theorem says that if you have a triangle and you draw the line out from a side of the triangle and make an external angle, so that would have been what number 2 is an external angle for this smaller internal triangle. This angle, number 2, is going to equal whatever the opposite angles are going to be added together. And so if you know that angle 1 is going to be 61, so 61, and you know the other opposite angle is going to be 90, that also is a way that you could have gotten 151. So it's 151 using the external angle theorem, or 151 using the fact that it's supplementary to 29. Either way, however you want to go with that, it still works. Let's see. Oh, yeah. Now we're on to the last one here. So use the figures below to find the measure of each angle listed. All right. So DAC. Oof. All right. Let's take a look here. Well, DAC and AC. Okay. All right. So DAC and ACD are both going to be equal to each other. The way that I know that is because DAC and CAD, yep, DAC and then ACD are both, they're both inside. So this small triangle here with the 92 degrees at the corner, that's an isosceles triangle. And I can tell because it's got the two little hash marks here. So this is a nice smaller isosceles triangle. So angle A here is going to equal angle C here. And so I've got 92 degrees here. So 180 minus 92 is going to give me 88. So that means that DAC is going to be 44. And then ACD is also going to be 44. All right. ABC. Oh, I see what I have to do. All right. So these are also going to be equal to each other. So this one are also going to be equal to each other. So if there's a way I can figure out what this angle is, then I can figure out what these two are going to be without any issue. I don't even need the rest of these at all. because this hash mark and this hash mark mean that the angles opposite them are also going to be congruent. So how do I find this angle? Well, I know that this is going to be equal to 44. Well, if I know that that's going to be equal to 44, I know that the angle next to it is going to be its supplement. So 180 minus 44, this is going to equal 136. So if this is 136, that means 180 minus 136, that there are 44 degrees left unaccounted for. That means that between these 2 degrees, between these 2 angle measurements, I've got to come up with 40. That means between these 2 angle measurements, this plus this has to equal 44. So let's see, I've got measure of angle ABC and then measure of angle BAC. So that means 22 and 22, because that's equal to 44 divided by 2. So 136 plus 22 equals 180. So there we go. So hopefully that's a challenging enough review for you ahead of the assessment. The next step is the assessment, and then we move on to happier times or happier things. No, we won't. We'll still be sad.